Hello everyone, hope you all are doing great. Guys, today in this video we are going to understand route filtering. So this is very important for network engineer to understand route filtering, how you will filter unwanted network. So first of all, what is unwanted network? So guys, let me make you understand what do you mean by unwanted network. So here in this topology, as you can see, I have created some loopback on router number 1, these loopback. So you can consider this loopback as your LANs, right? That means there are multiple LAN connected with router number 1, or you can consider that router 1 is receiving this network information from their neighbor, from any other router, and router number 3 don't need to send traffic to the user who belongs to these all network. That means router 3 don't need these network information in the routing table, yes or no? Because router 3 never send traffic towards this network. So if you will configure EIGRP as number 10 on this router also, on this router also, and on this router also, what router 3 will do? Router 3 will receive these all prefixes. It will install it in their topology table, in their routing table, yes or no? So inside the routing table of router 3, you will see these all prefixes will be there, yes or no? But these are unwanted traffic for router number 3, because router 3 don't need to send traffic to these network. So here on router number 3, I need to filter these prefixes so that router 3 cannot install these prefixes in the routing table. Because if router 3 is not going to use this network, then why router will install these all prefixes in routing table? Why router 3 will keep these all prefixes in the routing table? So unnecessary size of routing table of router 3 is large. So what we can do, we can filter all unwanted traffic from the routing table of router 3. Not only these prefixes. Suppose in the routing table of router 3 there are 1500 unwanted prefixes or 500 unwanted prefixes. So as a network engineer, you need to filter those all 500 prefixes, yes or no? Because router should install the prefixes in routing table that router need to use, yes or no? If router is not using, if router is not forwarding any traffic to this network, so why router 3 will keep these prefixes in their routing table, yes or no? So here we come up with route filtering. So guys, today we are going to understand route filtering in EIGRP. So the tool, or you can say the feature which we have to filter unwanted traffic in EIGRP is nothing but distribute list. That is distribute list. Okay, so we will use this tool to filter route in EIGRP. Now guys, what is distribute list? Distribute list is a tool which is used to filter unwanted traffic. Now who will tell to distribute list about the unwanted traffic, yes or no? Because we have to tell to distribute list that these are unwanted prefixes, yes or no? So the tool which we have to identify, to specify the unwanted traffic is, actually we have four tools for that. First one is standard ACL. Standard access control list. Second one is extended ACL. And third one is Prefix-List. And fourth one is route map. And guys, route map is the tool that nowadays we are using. Most of the organizations are using this route map feature to filter unwanted prefixes. Okay, so hope now it's clear to you what we are going to learn in this video. Okay, we are going to filter unwanted traffic from the routing table of router, from the topology table of router. So we have this feature distribute list to filter unwanted traffic, and we have 4 component, or you can say 4 parameter that will tell to distribute list about the unwanted traffic. Okay guys, so here in the event G I have designed this topology, same topology. First of all, we are going to understand basic distribute list, then we will discuss advanced distribute list as well guys, advanced route filtering as well. Okay, so first of all, suppose my requirement is here router number 3 is receiving these all prefixes. but router 3 never send traffic to this network. So I need to filter these all prefixes from router number 3. So what I can do, I can filter this traffic on router number 2 also, on router 2 on F1/0 in odd direction, so that it will not forward these prefixes from this interface, so router 3 will never receive it. Or we can filter the prefixes on this interface, on 0/0 interface in indirection, so that router 2 will not install. But if you will filter these prefixes on F0/0 of router 2 will also not install these prefixes in routing table. But suppose router need these prefixes, only router 3 don't need these prefixes, so you cannot apply it on F0/0 of router number 2. And you can apply it on router 3 also, in which direction? In indirection. Yes or no? So first of all, we are going to filter these prefixes by using a standard access list, a standard access control list. Okay guys, ACL. So let me show you first of all that router 3 is receiving all prefixes of router 1 or not. So this is my router 1. Let me take you on router number 3 directly. Here it is. Enable. So IP root EAGRP. So you can see router 3 is receiving these all prefixes. Yes, and I am able to ping 10.1.1.1 from here. Yes, but router 3 don't need to send any traffic, right? Router 3 never send traffic to this network. So what I can do, I can filter it. Yes or no? Because unnecessary router is installing. So IP EAGRP topology. These all prefixes in topology table as well. These all prefixes in routing table as well. Okay guys, and so IP route. So there are lots of prefixes in the routing table of router 3. But I want to filter only 10 prefixes, right? These prefixes. Router 3 don't need to never send traffic to these network. So what I will do, first of all, I will create one standard access list. So let's say access list number 1 and say deny. After that guys, network. So network is 10.1.0.0 wildcard mask 0.0.255.255. Here you can see in this entry, in this statement, all network will match. Yes or no? Definitely yes. Okay, and if someone will ask you that what is the definition of distribute list, so you can say distribute list is a feature of EAGRP that we can use to filter unwanted traffic. Done guys? Or what you can do, you can calculate a summary address of these all prefixes and you can filter that also. Now I need to, by default implicit deny is enabled, so let me run one more command, more statement with same sequence number, that is permit any. Done guys. And now router EAGRP 10. So you can apply it on F0/0 interface also, and you can apply it in EAGRP also, right? So I am applying it on in EAGRP. So say here distribute list and then access list number. So access list number is what guys? 1, and then you will define the direction. So in direction I want to filter it. And now if you will check routing table, so IP root EAGRP, you can see still these prefixes is available, but router 3 is going to resynchronize their EAGRP neighbor soon. Here you can see the log message, and after that it will filter the prefixes. So IP route EAGRP. Now you can see all 10 prefixes is filtered over here. Yes or no? So this is how we can filter prefixes by using a standard ACL, a standard access list. Now I am going to remove this configuration, router EAGRP 10, and say no distribute list number 1 and indirection. Yes or no? Now I am going to remove access list also. No access list number 1. Done. If you want to verify it, so IP access list. You can see I have not configured any access list, and so run section EAGRP, section EAGRP. So here you can see. So you can see in EAGRP I am running only 2 commands. Okay guys. Now suppose I have a scenario like this, not like this. Suppose I have some router R1 R1 is connected with one switch, and this switch is connected with another router R2, and R2 is this switch is also connected with one more router R3, and here I have one router R4. Let's see, this is my topology, and here I am running one network 10.1.1.0/24, or suppose X network. Here I am running what network? X. Done. So router 3 will receive X network from two sides, from router 2 also and from router number 3 also, with same metric, with same AD value. Yes or no? Because on all routers I am running what? EIGRP 10. So it will receive X network from here also and from here also. Suppose here I am running IP 12.1, here I am running IP 12.2, here I am running IP 12.3. So what I want to filter X network from router 2 only, right? That I don't want to receive the information of X network from router 2. I want to receive X network information from router number 3. So here we cannot apply, we cannot achieve our task through a standard ACL, because this time I need to define source as well, that filter those prefixes where source will be this one and destination will be X. So here you cannot define source and destination with the help of a standard ACL. So here we need to use what? Extended ACL. Here we can make a statement on router number 1 that access list, let's say 101, deny EIGRP or deny IP source host 12.1.1.2 and destination is, let's say, any, right? And here you will define one more statement with permit statement. Permit IP any, source any, destination any. Yes or no? And you will apply this access list in distribute list. So it will filter the prefixes which is coming from router number 2 only. It will not filter the prefixes which is coming from router number 3. Okay guys, so this is how we can filter prefixes by using extended ACL. So in extended ACL there are some limitations that we cannot achieve by extended ACL. So we have second type of parameter, second types of, you can say, tool that we can use to filter prefixes is nothing but extended ACL. Now these two are very basic, everyone knows, right? The route filtering by using extended ACL and extended ACL. Now we are going to understand what prefix list. So guys, suppose here in the network my requirement is router 3 should not receive these 3 prefixes only, or not like that. Suppose on router number 1 I am running some other loopback. Let me show you here. Suppose on router number 3 I am running some loopback over here. Let's say 30.1.1.0/24, 2.0/25, 30.1.3.0/26, and 30.1.4.0/27, 30.1.5.0/28, 30.1.6.0/29, and 30.1.7.0/30. Okay, suppose these loopback are running on router number 1 and on router number 3. This loopback is running on router number 3, and on router number 1 I want to filter prefixes whose length is starting from 25 and whose length is ending over 28, right? So this is prefix length. So I want to filter all prefixes whose length is starting from where? 25, and whose length is ending over here on 28. So in access control list we don't have any feature that we can filter traffic with the help of prefix length. So that's why we have third type of tool, that is prefix list. Through prefix list we can filter prefixes with the help of prefix length. Okay guys, so now what I am going to do, I am going to create some loopback on router number 3 here. Let me show you practically guys. On router number 3 I am going to create one loopback. Let's say interface config t interface loopback 1 IP address, let's say 30.1.1.1 255.255.255.0. interface loopback 2 IP address is 30.1.1.1 2.1 and subnet mask is 255.255.255.128/25. loopback 3 IP address is, let's say 192, that means /26, and here it is 3. Let me create one more loopback 4, and here subnet mask will become what, 224, and network ID will become 30.1.4.1. interface loopback 5, and here subnet mask will become what, 240, and 5.1 interface loopback 6 IP, here it will become what, 248, and network will become 6.1 loopback 7, and here it will become what, 250, and this is dot 7. So bad subnet mask, sorry, 252, and then okay, done. So I have created these all loopback on router number 3. Yes or no? Now I am going to advertise this loopback in EIGRP guys. Okay, so router EIGRP ES number 10 and network 30.1.0.0 0.0.255.255. This command will enable EIGRP on all loopback interface. Now on router number 1, if you want to verify that router 1 is receiving these prefixes or not, so IP route EIGRP. So you can see router 1 is receiving these all prefixes. Yes or no? Now I want to filter prefixes whose length is starting from 25 and whose length is ending over 28. Done. So in prefix list we have a concept. First of all, let me discuss that. One term is GE, one term is LE, and one term is 0.0.0.0. Guys, you all know 0.0.0.0 means what? All. Means all prefixes. And GE means greater than and equal to. Greater than and equal to. And less than and equal to is LE. Less than and equal to. Okay, so only these three terms are there in prefix list. So what I need to do here, on router number 1 I will create one prefix list. Command will be IP prefix list, and then you can define the name. Okay, so any name you can define, let's say CCNP. After that you can permit or deny, yes or no. So here what I am going to do, I am going to deny. Guys, which traffic you want to deny? 30.1.0.0/16. So here you can see in this network these all network will match, yes or no. And now I am not going to deny these all prefixes, yes or no, because my requirement is deny the prefixes whose length is greater than 25 and equal to 25 and length is equal to and less than 28. So here we will define it GE, greater than and equal to what? 25, and then LE, less than and equal to what? 28. Okay guys, and same with same name I need to create one more prefix list. IP prefix list CCNP permit 0.0.0.0 means any, yes or no, whose length is equal to and less than 32. Okay, so let me show you practically here. On router number 1 I am going to create one prefix list. Config T IP prefix list, and here we can, sorry, prefix list, and here we can define the name. Suppose my name of prefix list is CCNP, then deny, and then if you will put question mark, it is asking for network. So 30.1.0.0, here you have to match all network, yes or no, /16. So in this network all entry will match, right? And now I am going to say whose length is greater than and equal to what, 25, and whose length is less than and equal to what, 28. So it will filter how many prefixes? These all prefixes from here to here, yes or no? 30.1.2.0 to 30.1.5.0, yes or no? So let me show you. On router number 1, let me hit enter, and IP prefix list CCNP permit 0.0.0.0/0, right? Means all, and whose length is less than and equal to 32. Okay, so it will permit all the prefixes apart from these prefix. Now guys, I am going to apply it in EAGRP, router EAGRPS number 10, and distribute list. This time I am going to use what? Prefix list. Distribute list, prefix, and then name of your prefix list was CCNP, and in which direction you want to apply, in direction, right? Now if you will check routing table, so IP route EAGRP, still these prefixes is there, but soon EAGRP is going to resynchronize their neighborship. Just wait, you can see the log message over here. And now if you will check routing table, you can see, right, 30.1.2.0 to 30.1.5.0 is filtered, yes or no? So whenever you want to filter prefixes with help of prefix length, you can use what? Prefix list to filter the route. Okay, let me remove it. A router EAGRP S number 10, and say no distribute list prefix CCNP in direction, right? Now I am going to remove prefix list as well. No IP prefix list CCNP. Done guys, I have removed the configuration. Now again router 3 routing table, so IP route EAGRP, you can see all prefixes is there. Done. Now the last one and the important one is route map. So we are going to understand now route map guys. So see, through route map in prefix list, suppose router number 3 is receiving this prefix with this matrix, yes or no? So here with prefix list and with the help of ACL, we can note filter prefixes by using matrix value. We can note, filter the value with the tag number. In the last class we had discussed tagging as well. Yes, because on the router number 1, if you will run command, so IP route, you can see there are no any external prefixes is there. So I need to perform redistribution on router number 3, because on router number 3 I am running OSPF also, RIP also, and EAGRP also. So router EAGRP 10 and default matrix, I am setting default matrix. Done. And redistribute RIP, redistribute OSPF, process ID 1. So router 1 will have external prefixes as well. Now you can see it has all 50 network and all 70s network. 50 network is running in EAGRP domain and 70s network is running in OSPF domain, yes or no? Yes. Now on router number 1, I am not able to identify that these are prefixes of RIP and these are prefixes of OSPF. So what I can do, I can add tag, yes or no? So while redistribution, I can perform tagging as well. So let me do that. And through tag also we can filter. So let me remove the redistribution, no, and no RIP as well. Say no over here. No, right? Now I am going to create one route map to add tag. Route map, and name of route map is RIP _ tag and permit sequence number. If you will not define any sequence number, it will take what sequence number 10. And here I am not going to match anything, so it will match all. Now I am going to set tag 10, right? And let me create one more route map for OSPF route map, and name of route map is, let's say, OSPF underscore tag and permit. Here we can define sequence number as well, or if you will not define, no problem. Here I am going to say set tag 20. Done, guys. Now if you will verify route map, so route map. So you can see I have created how many route map? 2 route map. Yes or no? With same sequence number. Now while redistribution, I will call this route map config t router EIGRP s number 10 and redistribute rip route map name is rip underscore tag. So it will start tagging, right, tag number 10 with all rip prefixes, and redistribute OSPF process ID 1 and route map name of route map is OSPF underscore tag. Done, guys. Now on router number 1, if you will check topology table, you can see so IP route, so IP, let's say EIGRP topology. So see all these prefixes here, tag number is what? 10, and 70 prefixes, tag number is 20. If you want to check all prefixes of RIP domain, you can check it now. Yes or no? So IP EIGRP section include tag is 10. So you can see these are prefixes of RIP, and tag number 20. These are prefixes of OSPF. Yes or no? Now see on router number 1, I want to filter prefixes where matrix is this one. So I can do it with the help of what? Route map. And while redistribution as well, we can filter it. So here I want to filter the prefixes who have this matrix. So this type of requirement can be not achieved by Prefix-List and ACL. So here what I can do, I can use route map. So let me create one route map over here. Route map, after that name, let's say CCNP and permit. Done. And here I am going to what? Match. And what you want to match? Matrix. So matrix, and tell me the matrix value. So this is the matrix value. So it will match this matrix value. Yes or no? And now guys, I am going to do what? I am going to filter it. So exit router EIGRP s number 10 distribute list route map, and name of route map is CCNP. And in which direction you want to apply this route map? In direction. Now if you will check the topology table, tag is 10. Still prefixes are there, but soon EIGRP is going to resynchronize their neighbor. Then you will see these all prefixes will filtered out. Yes or no? Now you can see still these prefixes are there. What is happening? So route map. So I have created one route map. Okay, so I need to define the deny statement over here. So I have okay guys, so first of all I am going to remove this configuration router EIGRP s number 10, and let's say no over here, no. And let me remove route map as well, route map CCNP, say no. Right, again I am going to create route map with what name? Same name, CCNP, and deny, and I am not defining any sequence number, so it will sequence number what? It will take sequence number 10, and match matrix, this one, matrix, match matrix. Let me check matrix. So this matrix, match matrix this. Okay, and with same name I need to give one permit statement. So route map CCNP permit, and I am not matching, so it will match all. Done. Router EAGRP is number 10, distribute list, route map CCNP, direction in. So IP EAGRP topology include tag is 10. So now you can see, is there any prefix, guys, with tag number 10? Yes, still prefixes are there. Yes or no, sir? That means I am not able to filter prefixes with the help of metric value. Yes or no? What wrong I am doing over here, guys? So route map. So see here, sequence number is 10, and where is permit statement? This is permit statement, guys. Where is deny statement? So actually we have to define the higher sequence number, otherwise it will overlap the entry, right? So let me remove route map again, guys. Route map CCNP, say no, and route map, this time route map CCNP deny and match what? Metric, and tell me the metric now. This one is metric. Yes, exit. This time route map CCNP and permit with higher sequence number. So here I am going to define sequence number what? 11, and I am not going to match anything, so it will match all. Yes or no? So now do so route map. Now you can see I have two route map over here. Now I will apply this route map in EAGRP, router EAGRP 10, and distribute list, route map name is CCNP and direction is in. It soon EAGRP neighborship is going to resynchronize. So IP EAGRP topology include tag is 10. So now you can see, is there any prefix? No. Tag is 20. Is there any prefix? No. Because 10 prefixes and 20 prefixes, all prefixes were coming with same metric value. Yes or no? But I want to filter only these prefixes, right? Not 70s prefixes. Yes or no? Not OSPF prefixes. Where is the entire topology table? Here it is. See, here also metric value is same. So here we can filter the prefixes with the help of tag number, not metric, because OSPF prefixes is also coming with same metric value. Okay, so if you will filter prefixes with metric value, it will filter all prefixes of RIP also and OSPF also. So again I am going to do what? I am going to remove the route map, router EAGRP 10, say no over here first, and no route map CCNP. Done. See here, now again it will install all prefixes. Yes or no? You can see tag number 10. So it have received all prefixes of RIP, all prefixes of OSPF. Now I am going to filter these prefixes with help of tag number. So what I am going to do, again I need to create route map only. Route map name CCNP and permit. Let me define one sequence number as well, that is 10. Done. And this time I am going to match what? Sorry guys, not permit. Here I need to define it, deny. Say no. And route map deny CCNP, sequence number is 10. Done. And here I am going to match what? Tag. Match tag. And tag number is 20. 10. Sorry. 10 is the tag number of EAGRP prefix. Yes or no? Okay. And if I am denying one, it will deny all. So let me create one more route map with same name. Route map CCNP, and here sequence number will be higher. Permit sequence number is, let's say, 11. And I am not going to match anything, so it will match all. Now router EAGRP 10 and distribute list route map name is CCNP, and which direction, guys? In direction. Now if you will check, so IP EAGRP topology include tag is 20. So it have all prefixes of OSPF, yes or no? But here if you will run tag is 10, you can see. So all RIP prefixes is filtered over here. So this is how we can filter prefixes with the help of tag number. Okay, guys. So actually these are very basic route filtering. If you are a network engineer, make sure you have knowledge about these things, that how we can filter prefixes. We can filter prefixes by using a standard ACL as well. We can filter prefixes by using extended ACL as well. We can filter prefixes by using Prefix-List as well. We can filter traffic by using route map as well. In route map we have lots of options, right? We can filter traffic with the help of metric, with the help of tag number, and many more feature is available, right? So those features we will discuss in upcoming days, not today. So today for this video, I think everything I have covered, right? In this video actually I was thinking to cover route map, prefix list and access list. So I have covered these things. Done, guys. This is all for today. If you have learned something from this video, please hit on like button. Bye bye.